All right, guys, let's go ahead and start. Here we go. Everyone happy? Yes, I'm glad that you guys are happy. This will be the last notes. And after this, that's it. Then we will start testing on Monday. And after we're done with this, we'll let you catch up with whatever it is you got to catch up. And then tomorrow we'll have like one little small activity. And that's it. Done. Delta math, and then look over your notes, and then look over all your activities. I think I have some papers to pass out, like that belongs to you guys. And
Can we test this?
yes, everything that's in here will also be tested. All right, guys. So we're not going to leave you out of the park. I put some free response questions so you guys can have some free response experience. Don't worry, we're going to do these together. All right. So let's start with the first example, guys. This is coming from the circuit, the one that I told you guys to hold on to. Because I wanted to talk about it. And I know that I said I was going to type out a whole bunch of questions like this, but I'm like, nah, let's just go right into the review. So here it is. During a severe rainstorm, water enters a catch basin at a rate of R of T. So this is how much it's going into that basket. I'm just going to call it a basket. Where X is time in hours over the course of 4 hours. Water leaves this basket via a drain at a rate of L of T. So this is how much is coming out. Find the time between 0 and 4 at which the water in the catch basket is decreasing at the greatest rate. All right, relax. This already is a rate. Does that make sense to you guys? So I want to know, when is the rate, the number, the biggest negative number, or the furthest left? Does that make sense? On a number line, the further you are left, the smaller it is. So that's what they want to know. That's what it says. Which water in the catch basket is decreasing at the greatest rate. So what I'm going to do, here's my net. I'm going to use N for net. My net rate is the amount going in, negative T squared plus 4T, minus the amount going out. Does that make sense to you guys? All right. So combine like terms. Here's my new equation. Negative T squared plus 2T. How do we feel so far, guys? All right. I want this number to be the smallest possible number. So I'm looking for a minimum. So if I'm looking for a minimum, I have to take a what? A derivative to find critical numbers, and I'm also going to test my endpoints. So here it is. N prime equals, what's the derivative of negative T squared? Negative 2T plus 2. And I'm going to equal this to what? 0, and I'm just going to solve for T. So when I do that, negative 2T equals negative 2. I get T equals negative 1. This is a candidate. Because you have a close... Oh, yeah, there's no such thing as negative 1. I was testing you guys. Ha, ha, ha. Because I have a closed interval, I'm going to just check that critical number and then my closed endpoints, 0 and 4. Cool or not cool? So here's my little table. I'm going to put T, and I'm going to put N. I'm looking for my net rate. I'm going to put 0. Well, if I plug in a 0, let's see, I'm right here at this one. 0 squared and 0 is 0. So nothing has come in. There's no water in, there's no water out. So let's see, now I'm going to plug in the value 1. If I plug in a 1 plus 2 is 1. Oh, did I do that right? Negative 1 plus 2, yeah. Do you guys see what I'm doing there? No? Okay.
John, we're plugging it into
Original. Yes. I'm plugging it in here, guys. I'm plugging it in right there. 1 squared is 1, but I have a negative in the front. So negative 1 plus 2 is 1. So at T equals 1 hour, there's water that's increasing in the basin because there's more water going in than out, obviously, because it's positive. And at 4, let's see, 4 squared is 16, so negative 16. 2 times 4 is 8. Negative 16 plus 8, negative 8. All right, when is water leaving at the greatest rate? At 4, yeah. So the answer is, they want to know at which time, find the time. So the answer is T equals 4. And I would write a little sentence. So how would I write it? I would write it like this, guys. I would just answer the question. The water in the catch basin, is it basin? Basin is decreasing at the greatest rate at t equals 4 hours, period. Full credit.
Are you going to write sentences on our free response question?
I would write sentences. Just don't, not a whole paragraph, not a whole essay, just one sentence answering the question. As long as you state facts, you're fine. How do we feel? Yay. Okay, we got that question out of the way finally. Sorry that it took so long, guys. All right, here we go. Hey, no yawning. All right, example 2. So here we go, free response style. Find the intervals on which the function f is decreasing. Justify your answer. So I don't have a calculator. We don't have a calculator for this. So NC, no calculator. How do I figure this out? I got to take a what? Derivative. So f prime of x equals, let's see, e to the negative 2x is going to be negative 2 e to the negative 2x minus e to the x. Oh, now what? I would do this, guys. Do we know? Yeah, I would not factor e to the x. I would just factor, it looks like I would just factor a negative. So I would just do this, negative e to the negative 2x plus e to the x. And I'm going to do a side note. Oh, yeah, man. What's going on with me today? I'm going to blame it on lack of sleep. No excuses. Okay. Are we still okay right now, guys? All right. Side note. E to the x is always positive. 2e to the negative 2x is always positive. So now that you know that, this expression that I'm circling is always positive. Bless you. But look what you have on the outside. Negative. So I'm going to write this. I'm going to write f prime of x is always negative for all x. So that means what? That this function is always decreasing. Perfect. So I'm going to say, so here we go. I'm going to say f of x is always decreasing over its entire domain. And if you want to write a domain or negative infinity to infinity.
Are we just placing and bistery?
Yeah, I think you guys are. But let's not talk about that right now. Are we okay so far? All right. So now let's look at this one, guys. Don't worry, we're going to finish pretty quick today. Find the value of the limit as x approaches 0 of f of x divided by arctan of x. All right, before I continue, what is arctan of 0? Oh, man.
1.
Arctan of 0 is 1?
0.
Arctan of 0 is 0, guys. So that means tan of what radian is 0. And now look, notice it says f of x here. So now look, here's f of x. If I plug in a 0, I get 1 minus 1. What is 1 minus 1?
0.
0. So this looks like I have 0 over 0. What can I use? L'Hopital's. Perfect. So state that first. First state the numerator and denominator by itself. Right. Limit as x approaches 0 of f of x equals 0. And then I'm going to write limit as x approaches 0 of arctan of negative 1 of x equals 0. Because both of these are 0, I can use what? Yeah. We may use L'Hopital or hospital or whatever. All right, here we go. Limit as x approaches 0 of f prime of x divided by, what's the derivative of arctan? There you go. Now it looks like I can plug in a 0. So I already have my derivative here. Let's see, if I plug in a derivative, if I plug in 0 in there, I get 2 plus 1. 2 plus 1 is 3, but what I have on the outside? Negative. So I have a negative 3 over 1, so you get negative 3. That's my limit. Is this making sense, guys? Wait. It's not making sense? Okay. Sorry, miss. Okay, I'll stop. I'll stop. All right. Here we go, guys. Next one. Oh, hey, Delmer. Okay. She didn't say hi to me. Letter C. It's still part of the same one, guys. It wants me to find h prime of 1. What rule do I have to use? Start the letter C. Oh, not everyone at the same time. Chain rule, guys. Chain rule. Derivative of the outside, f prime, leave the inside alone, x cubed minus x, times derivative of the inside, 3x squared minus 1. Now I'm going to plug in a 1. H prime of 1 equals f prime of, 1 minus 1 is 0, times, 3 minus 1 is 2. So I'm going to look for f prime of 0. Oh, I already have f prime of 0, right? What's f prime of 0? So, h prime of 1 is equal to negative 3 times 2, which is done. Yeah, it was that bad. It wasn't that bad. There it is. That's it. I plugged in, this says f prime of x, and I plugged in 0 into f prime. So there's my derivative right here. I just plugged in a 0 right here and right there. So 2 plus 1 was 3, and then there's a negative on the outside. She okay?
Why would you do the derivative of the inside again?
Yeah, you already did the derivative of the inside. There's no more insides. Okay. Okay. No fighting. All right, here we go. These questions are coming back. There's actually a whole course dedicated to this, non-homogeneous differential equations, and it's called DiffyQ when you get to college for you engineers. These questions are coming back. They're starting to become more and more popular. So relax. It's not like you don't know how to do it. You do. You just got to go slow. It says this. Here's what it says. Verify that y equals e to the negative 2x minus e to the x is a solution to the differential equation blah. All right, I already know what y is. Figure out what y prime is. So y prime equals negative 2 e to the negative 2x minus e to the x. Are we still okay? Yes. Now I need to figure out what y prime prime is. Y prime prime. Y prime prime is, negative 2 times negative 2 is 4 e to the negative 2x minus e to the x. I'm going to put them in order, in this order. So I'm going to write, y prime prime plus y prime minus 2y equals, and I'm going to write it, giant parenthesis, 4 e to the negative 2x minus e to the x, that's my y prime prime, plus, negative 2 e to the negative 2x minus e to the x, minus 2 times e to the negative 2x minus e to the x. It's not that many. I put the giant parentheses in case there's like a negative in the front and I have to distribute. I don't. So we're going to drop those parentheses like it's hot. Because when something's hot, you drop it, right? Yes, I am. So here we go. I'm going to drop the parentheses and distribute that negative 2 there. 4 e to the negative 2x minus e to the x plus a negative, so minus 2 e to the negative 2x minus e to the x minus 2 e to the negative 2x plus 2 e to the x. I'm going to color code. What is the same, I guess. So let's see. 4 e to the negative 2x, bless you. Bless you. So check this out. So those that I just color coded, negative 2 minus 2 is negative 4. Do those cancel out? Yes. All right, now I'm going to color code the other one in green. So I have e to the negative x, negative e to the x, negative e to the x, and 2 e to the x. Do those zero out? Yes. All that mumbo jumbo equals 0.
Are you serious?
Yes. And then you can write hence y prime prime plus y prime minus 2y equals 0.
Is there a way we could have pulled that in the beginning?
No, well, we can't say it in the beginning until we do the math. And then once you do the math, you can say it. Are we okay, guys? All right, here we go. Let's continue. All right, guys. All right, guys. All right, you guys ready? Don't worry, we're almost done. Look, it's not even halfway to class yet. Example 3. Consider the function x to the power k minus 3x squared plus 1 where k is a non-zero constant. Let k equals 2 so that the function f of x equals blah. Explain why there must be a value c between negative 1 and 2 such that f prime of c equals negative 2. All right, when you read this statement and you read this right here, what does it make you want to do? There's a theorem, a very famous one. MVT. MVT, guys. Look, it says derivative there. So it makes me want to do this. F of 2 minus f of negative 1 divided by 2 minus a negative 1. If this equals negative 2, it guarantees that my average rate of change better equal my instantaneous rate of change somewhere on that interval. I probably need to state that in order for me to use mean value theorem, I have to be continuous on negative 1 and 2 and differential on negative 1 and 2. And it is because it's a polynomial. So I'm going to write, here on the side, I'm going to say f of x is continuous, negative 1 comma to 2. Notice that I put brackets, and then I'm going to write f of x is differentiable, negative 1 comma to 2. Notice that I put parentheses. For MVT to work, it has to be continuous on A to B, but differentiable on A to B, on the open for A to B. Does that make sense to you guys? Okay, here we go. I'm going to find out what f of negative 1 is. F of negative 1, negative 2 times negative 1 squared plus 1. We have no calculator. Negative 1 squared is 1. 1 times negative 2 is negative 2 plus 1 is negative 1. So that's f of negative 1. Now I'm going to figure out what f of 2 is. Negative 2 times negative 2 squared plus 1. Negative 2 squared is 4. Oh, yeah, man. Why am I making so many mistakes today? What the hell? I'm sorry, guys. I want to go to heaven. What the heck? 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. All right. So equals, let's see, negative 7 minus a negative 1 divided by 2 minus a negative 1. That's 3. Negative 7 minus 1 is, so that's going to turn to plus. That's negative 6. Negative 6 divided by 3 is negative 2. Let's look at that. What's the average rate of change? So by mean value theorem, so I'm going to state, so there it is, and I'm going to state just this. By MVT, comma, there must be a value C, comma, for, I'm just literally copying this part right here, for negative 1, C2, comma, such that f prime of C equals negative 2. There's my sentence, there's my work, full credit. Here's the key, guys. You must have this. Everything here you see in blue, you must have that. If you have that, then you can just write by MVT. How do we feel? All right, let's look at letter B. Let k equals 3 so that f of x equals blah. Explain why there must be a value r between 2 and 4 such that this one doesn't have derivative. It says f of r equals 0. What theorem can you think about? There's only like, which one? Not Rolls. Rolls is MVT again. Rolls is MVT. It's a special case. What, guys, think about it.
Wait, what was the question?
It says, for k equals 3, explain why there must be a value r between 2 and 4 such that f of r equals 0. Yeah. What does IVT mean? Intermediate. Yeah, but what is it? How do I prove it?
That means that it has to pass it. It has to pass that. That 2 has to be negative and 4 has to be positive.
Perfect.
Vice versa.
That's perfect right there. Did you guys hear what that means? All right, I'm going to say it. I'm going to stop real quick. You do not, by the way, on the AP exam, because I'm not teaching to the test, guys. I don't want you guys to. We're going to talk about it when we get close to it, but I'm not trying to teach you the test. It's IVT. Let's say you forget the name of the theorem. Relax. You don't have to name the theorem. All you got to do is prove this. You plug in a 2, you're going to get some number, either positive or negative. If you plug in a 4, you better get the opposite sign. If you get the opposite sign, then that proves that you crossed the x-axis, or in this case, the r-axis. Does that make sense? Because there's no way you can go from a positive to a negative, or vice versa, without crossing the r-axis. Cool or not cool? Cool. So that's what I'm going to do. If you can remember the name of the theorem, more power to you. So here we go. I'm going to find out what f of 2 is. So I'm going to write f of 2, and I'm going to write 2 cubed minus 3 times 2 squared plus 1. 2 cubed is 8. 2 squared is 4. 4 times 3 is 12. 8 minus 12 is negative 4. Plus 1 is... All right, so I'm going to check the fourth one, and it better be a positive number. F of 4. Uh-oh, let's see if we can do this. 4 cubed minus 3 times 4 squared plus 1. All right, 4 times 4 is 16. 16 times 4, I want to say that's 64. All right, let's see. 4 squared is 16. 16 times 3, 16, 32, 48. So 64 minus 48 plus 1. All right. 64 minus 48, is that 24? No. 16? Oh, my bad. 16, and then 16 plus 1? 17. So, did I change signs? Yes. So, here's one of two ways that you can write it. So, here's the first bullet. I'm just going to write it by IVT, comma, there must be a value r for 2 less than r less than 4, comma, such that f of r equals 0. That's one way to write it. The one in blue is probably the way I would have written it if I were in crunch time. So this one in blue is probably how I'm going to wait till you guys finish, so I can see some of you guys writing. If I'm in crunch time and this is a real AP exam and I'm just going as fast as I can, and let's say it doesn't even cross my mind to say intermediate value theorem, I would probably say this, because you're logical. I would probably say this. I would probably say, since f of 2 is negative, comma, and since f of 4 is positive, comma, and f of x is continuous for all x values, comma, there must be an r value for where f of r equals 0 on this interval. Oh, that's not an essay. That's one sentence. Well, I think this one in blue makes more sense. No?
It does make sense because it's just IVT.
Yeah, look, I don't say the word IVT. I just say, since f of 2 is negative and f of 4 is positive and f of x is continuous for all the x values, there has to be a value r where f of r is 0 on this interval. Did I say anything wrong though? No. You can always write more, but you gotta make sure that. All right. I guess maybe see if we can. We'll practice. We'll practice a whole bunch during crunch time, and maybe we'll get it looking like the one in red all the time. All right, here we go. Don't worry, guys. We're almost done. Let k equals 4 so that f of x equals blah. Write an equation for the line tangent to the graph of f at the point where whose x coordinate is 2. All right, I need a tangent line. I need two things. What and what? Point and a slope. They almost gave me the whole point. They haven't yet.
Mr. Chavez, could you please post a ticket?
Yes, ma'am.
Thank you.
So let's find the point. Plug in a 2 in there and tell me what you get for y while I take attendance before they fire me, because I don't want them to fire me. I want to do a whole bunch of math life all the time. I think everyone is here today. Oh. So everyone, I'm kidding, guys. Guys, I'm kidding. I was 100% kidding. I had to, because they're gonna hear this, right? Because I'm gonna put it on YouTube for one day.
Did you record, or just record the lecture?
I'm recording it right now.
You are?
Yeah. That's why this laptop is getting hot. You can hear the little fan. All right, what's the point, guys? 2,5? Did you guys already take a derivative and plug in a 2? All right, what is f prime of 2? What is it? 20? All right, here is what I recommend, that you always leave it. I would recommend you always do this and done. This is correct. It's a tangent line. It's an equation. If you are courageous, you can continue and solve for y. But as soon as you make a mistake, you're going to get it wrong. Cool or not cool? All right, let's continue to the next one. Let k equal 6. Find the absolute maximum value and absolute minimum value on this interval. Okay, again, I'm going to do a table. And I'm going to find the what? The critical numbers. So let's find out. F prime of x equals 6x to the 5th minus 6x. Oh, they're being nice to us. Equals 0. Factor out of 6x and you get x to the 4th minus 1. Oh, they're being real nice to us. That x to the 4th minus 1 is the difference of squares. X squared plus 1, x squared minus 1. And again, that x squared minus 1, you can do it again. 6x, x squared plus 1, x plus 1, x minus 1. Because it's the difference of squares again.
But why does it matter if we're just going to get the same numbers?
Yeah, you're just going to get the same number. So here are my values. 0, x squared plus 1 is never 0. Well, I guess it is if it's imaginary. X equals negative 1. X equals 1. So those are my 3 critical points. We don't have to test all of them. We do not have to test negative 1. Because it's not in the interval. Here's my little table. I'm going to write x and I'm going to write f of x. I'm going to put 0. I'm going to put 1. I'm going to put 2. The table is justification and we'll make sure, we'll guarantee that you get full credit into the original. When you plug in 0, you get 1. When you plug in 1, let's see, 1 minus 3 is negative 2 plus 1 is negative 1. When you plug in 2, relax. Hey, relax, guys. So look, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32 times 2?
64.
There it is. 64 minus 2 squared is 4. 4 times 3 is 12 plus 1. 64 minus 12, what's that? 52 plus 1? Okay, what's absolute max? At 2, which is 53. What's absolute min? At 1, which is negative 1. Did they want the value or did they want the x-coordinate? Find the absolute maximum value and absolute minimum value of f. Okay, I would write a quick statement. I would say that's a max. I would circle this one and say that's a min. And then I would just write one sentence. Absolute max value of 53, period. absolute min value of -1. If you want to state the coordinate where it happens, you can. Absolute max value of 3 at x equals 1. Absolute minimum value of -1 at x equals 2. Actually, I like that better. At x equals 2, at x equals 1. How do we feel? Are we getting better at this, guys? All right, guys. We are done with today's notes. I didn't make any new assignments, so see if you guys can finish up whatever you haven't finished up. If you already got a good grade on your UH, then you're good.